Okay, welcome back. So, for this next part, I've drawn two parallel lines again. Sorry about this little mistake over here, you can ignore that. And a transversal. So that's a line going down, crossing two or more other lines, okay? And for the sake of this work we're doing, it'll always be two parallel lines. Okay, so transversal, it's transversing or it's crossing these two lines. Now, this time I drew the transversal going this way instead of that way, just to show that it doesn't matter what direction the transversal is going as long as it's crossing over the two lines. Okay, so that's the transversal. And what I wanted us to see this time is how would you recognize corresponding pairs of corresponding angles and pairs of alternate angles and pairs of vertically opposite angles if you were asked to point them out in a question. So again, when we do this drawing, it creates 8 angles, and I'm going to give them a name. 1, 2, 3, 4, 5, 6, 7, 8. Okay, creates 8 angles. And the key, or I suppose a good way of remembering how we're going to find our corresponding alternate and vertically opposite angles is by using this code up here, if you like. Now this is also in the book, so you can see it there if you like. So whenever you can create a Z shape, you will see the alternate angles. If you can create an F shape, you will see corresponding angles. And if you create an X shape, you'll see vertically opposite angles. Okay, so how do we create those Z, F and X shapes? Well, normally all you have to do is cover some parts of your drawing here in order to leave you with a Z, an F or an X. So let's start with the easiest one, I suppose, the X shape. Now, if I cover, I'm just going to get a piece of paper, maybe a bigger piece than that. If I get a piece of paper and I cover the bottom half of this drawing, I'm left with this kind of X shape, these two lines crossing over. You have this X shape, and you already know from the work you did with Mr. Mernan that the opposite angles here in this X shape are vertically opposite angles and they're equal. So angle 4 is equal in measure to angle 2, angle 1 is equal in measure to angle 3. Same goes here. If I cover the top, then down here I'm left with this X shape. These two lines are making an X shape. And again, angle 6 is equal in measure to angle 8. They're vertically opposite angles. And angle 5 is equal in measure to angle 7. They're vertically opposite angles, or they were a pair of vertically opposite angles, if you like. Okay, so that's the X shape. Next, how would I recognize corresponding angles? By creating this F shape. And when I say create an F shape, it could be a forward-facing F, a backwards F, an upside-down F, an upside-down and backwards F. Okay, any F shape will show you the corresponding angles. So I'm going to try and create some F shapes here first of all. So we know that F is normally this kind of a shape. So if I just had this line, and this line, I would have an F shape created already. So I'm going to cover these other bits of lines here. So that's covered up. I'm going to cover the top here. And you can see I'm left with this F, hopefully. See the F? And when I'm left with the F shape, there are just 3 angles left uncovered. And 2 of them must be corresponding angles when we make our F shape. And there's, I suppose, 2 ways of deciding which of the 2 are the corresponding angles. Well, corresponding angles, or pairs of corresponding angles, are equal in measure. And we can see that angle 3 is acute, angle 6 is obtuse, and angle 7 is acute, less than 90 degrees. So 3 and 7 must be the equal angles because they're both acute and this is obtuse. Another way of looking at it is when you create your F shape, the 2 angles which are either both underneath a line or both above a line are the corresponding angles. So 3 and 7 are both underneath, so they're the corresponding. 3 and 6 couldn't be because one's underneath and one's above a line. Okay, so that's one F shape. So one pair of corresponding angles is angle 3 and angle 7. They're equal in measure. Let's see if we can create another F shape. So let's this time go for the right side up, but facing backwards. So again, if I cover the top, and then I cover this side, we have this F going in the opposite direction, facing in the opposite direction. But again, it leaves me with 3 angles angle 4, angle 5, and angle 8. And again, if we use our rule of thumb that it's the two angles which are either above or below a line, 4 and 8 are below these lines here, so they're the corresponding angles. They're equal in measure to each other. Okay, that's 2Fs. The next thing, maybe try an upside down forward facing F. So if I get rid of this, cover that up, and get rid of this down here, whoops-a-daisy, we can see I'm left with this upside down forward facing the right direction, but it's upside down, this F. And if I have that again, I'm left with 3 angles with this F. And again, the 6 is above a line and the 2 is above a line. So the 6 and the 2 are corresponding angles. The 3 is below the line, so it's like the odd man out. So it's not a corresponding angle to either one of these. Okay, last one, because there should be 4 pairs of corresponding angles here. The last one is going to be, excuse me, we had a upside down one facing this way. Now we want an upside down one facing this way. So if I cover this first of all, and then I cover this here, you can see again that I have this upside down F facing this direction over here, and I've got 3 angles again, and again 1 is above a line, 5 is above this line, so 1 and 5 are the corresponding angles. And you can see again 1 is an acute angle, 5 is an acute angle, less than 90 degrees. 4 is an obtuse angle, so it's not equal to either one of these. So these must be the 2 corresponding. Angle 1 is equal in measure to angle 5 because they're corresponding angles. Okay, that's the corresponding. Now, last one is how do we recognize alternate angles? We look for a Z shape. Now, there are only 2 pairs of alternate angles in any of these drawings, okay? So there are only 2 Z shapes we look for, a backwards and a forward-looking Z. And we know that in a Z, the bottom line of the Z and the top line of the Z are parallel to each other. So it's this line and this line, the 2 parallel lines, that make the bottom and the top of the Z, and this middle bit that makes this middle bit in the Z. So what we need to do is just create a forward facing and a backward facing Z. So first of all, if we cover, we need a bit more paper for this one. If we cover this, maybe like this, and we have this going like here, cover the top of that. Okay, I'm going to cover the bottom here. And I'm going to cover, let's see, can we do this as far as here? It's difficult to do this with the one hand. Let me cover that. If we pretend you can't see this bit over here. So you can see that you've got this one line, one line, one line. So let's push that up a bit to cover it. So you get this one line going across, down, across like a Z. Okay, and you can see there are only 2 angles which are left uncovered, and those 2 angles are alternate angles. They're equal in measure. This one is obtuse, this one is obtuse, greater than 90 degrees. They're all a pair of alternate angles with a Z going in the right direction. Next, we'll try and create a Z that's going in the opposite direction. So again, we're going to want this Z here. Now, it isn't necessary to do all this covering up. I'm just doing it for the sake of illustrating it this time. But if you can see the Z shape without covering everything up and recognize this Z shape is going to create one angle here and another angle down here, then you know these are the alternate angles, 3 and 5. But we'll cover it up just to be on the safe side. So covering up the top like this. Covering up, let's see, the bottom maybe like this. Covering up this one. Now we already have this. We just need to cover this line here. There we go. So we get this. You can see we have this one line across, down, across, this Z going this way. And you can see there are only 2 angles which are not covered up, and that's angle 3 and angle 5. And they're the alternate angles, and they're again equal in measure. Okay, so again, I would say it's very important that you learn off that if you're looking for alternate angles, try and create a Z or find the Z, and there will only be two types of Zs here that you can create, one going forward, one going backwards. If you're looking for pairs of corresponding angles, try and create an F, and there will be 4 different Fs, a forward one, a backward one, a forward and upside down one, a backward and upside down one. So you'll have 4 pairs of corresponding angles, and the vertically opposite angles just create an X, and there should be again 4 pairs, 2 pairs for each X. 1, 2. And again the same 1, 2 down here. Okay,